This one is problem 1.27. It says a 4-engine jet transport which weighs 1000 kilonewton, fully loaded, has its center of gravity at the location shown in the sketch. Before taking off, a pilot must test the engine by operating them one at a time at a thrust of 40 kilonewton. So this is the engine right here which the pilot is testing. As he checks the left engine, the other 3 engines are idle and there is no thrust. The rear wheel brakes are locked during the test, but the nose wheel has no brakes. So basically these wheels that you see here, there will be friction coming on these, but there will not be any friction on this one right here. In addition, the nose wheel is mounted on a caster, so it cannot resist a sideways force. What force does the ground exert on the landing wheels during the test, and what must be the coefficient of friction between the ground and the wheels to be preventing the rear wheels from slipping? So let's mark the coordinate system here first. So if I take this side here to be x-axis, and vertically up is your y-axis, and towards this wing here is your z-axis. Okay, so on this figure here, this is your z-axis, this one is your y-axis here, and towards the nose we have negative x-axis pointing. Now looking at the forces, there will be a normal force here, normal force here, normal force here, a thrust pointing here which will be in the negative x direction, and your weight will be acting downwards there. Now on these two wheels we are expecting frictional forces here, so these frictional forces will be this way. So I can name these. This is FAY, and if this point right here is B, then FBY, FBX, FCX, and FCY right here. In the Z direction, on these two wheels here, we are not considering any sideways motion or sideways friction force. That's why we are ignoring that FB, Z and FCZ force. Okay, so first thing first, we can do the force balance on this. So if you do the force balance in the X direction, we can write FCX plus FBX equals to 40. Now in the Y direction, we have all the normal reactions, FAY plus FBY plus FCY, and all of this will balance your weight, that is 1000 kilonewton. In the Z direction, since we are ignoring that friction in the sideways, there is no force, so we are not writing that equation. So now if you notice here, there are total 5 unknowns here. Okay, so we have only 2 equations so far, so we need 3 more equations. So for that purpose, we'll do the moment balance, and one common point in this problem is your center of gravity G, so we can do the moment balance about G, and we are again going to use that R cross F setup for moment calculation. So for each one of the points, I can write our R value this side and force value here, so that it will be easy for us to do the calculation. So if I look at point A with respect to point G, how do I reach point A when I start from this point G there? So I have to come down here, so negative J, and the distance here is 3 meters, and I have to go leftwards, which is again minus X. So I can write minus 15 I cap minus 3 J cap, and in the K cap direction sideways we are not moving because this nose and the gravity is along the same line. So this is the vector. Now for the force, we can directly write it as FAY J cap. Now coming to point B, so from the center of gravity, from here, how do we reach this wheel? So we have to travel this distance 1 meter to the right side direction, so 1 I cap. We have to come down by this 3 meters, so minus 3 J cap, and again we have to move this one here along the Z direction, so plus 4 K cap. And in terms of force, there are 2 components, so FBX I cap plus FBY J cap. Likewise point C, everything else is same except that now this 4 meter distance, rather than going right, we have to go to the left. So this will be 1 I cap minus 3 J cap minus 4 K cap, and force wise we'll have FCX I cap plus FCY J cap. And the last one is this thrust, let's call that point E. So we'll have this right here. So in the x direction, we are moving by this 1 meter and 2 meter here. So this becomes 3 I cap. And in j cap, since your thrust is aligned with your center of gravity, so there is no movement there. And along the k cap direction, we are moving by 15 meters there. So 15 k cap. In terms of force, this force is going to be along the nose. So it's going to be in the minus I cap direction. So now if I simplify these movement values, your movement because of forces at A will come out to be minus 15 FAY in the K cap direction. The moment because of point B will be minus 4 FBY I cap plus 4 FBX J cap and plus 3 FBX plus FBY K cap. And because of point C, we are going to have 4 FCY I cap minus 4 FCX J cap plus 3 FCX plus FCY K cap. And because of the thrust from the engine, the net moment is going to be minus 600 J cap. So now if we collect all the I cap components here, which is this one right here and this one right here, we get an equation which is nothing but FV by has to be equals to FCY. So let's call this your equation number 3. Now when we collect your J cap terms here, which are these 3 right here, we get an equation which is FBX minus FCX is equals to 150. So this is your equation number 4. And the last one where we collect the K cap terms here, this one, this one, this one here, then we get an equation which says 3 times FBX plus FCX minus 15 FAY plus FBY plus FCY equals to 0. So this is equation number 5. So now we have these 5 equations and 5 unknowns. So for example, this equation may look complicated, but we know the value of this already from your equation number 1 here. So I can substitute this as 40. So this becomes 120 and this is minus 15 FAY, and this right here we can replace it as 1000 minus FAY. So this can be written as 1000 minus FAY. So now this is an equation only in FAY. So if I solve this, the value of FAY comes out to be 70 kilonewtons. And your equation 2 was already FBX plus FCX equals to 40. This was your equation 2. So now these 2 equations are only in FBX and FCX. So from here we can solve for your FBX as 95 and FCX as minus 55 kilonewtons. Now the last unknowns, which are FBY and FCY. So these, if I substitute the value of FAY in this equation, and we know that FBY is equals to FCY, so with this we can solve FBY equals to FCY equals to 465 kilonewtons. So these are all the forces that are acting on the wheels. So now for the requirement for the coefficient of friction, let's look at those 2 wheels. This one is your B and this one is your C. So in terms of normal force here, both of these wheels are the same amount of force, 465 kilonewtons here and 465 kilonewtons here. Now your FBX and FCX, which are the tangential forces, this value right here is 95 and this is minus 55. So from the perspective of a coefficient of friction, that will be the tangential force value divided by 465 here and in this case it is 95 divided by 465. So this comes out to be 0.12 and this one is 0.20. So now to avoid any slipping happening there, both of these should be satisfied. So we need to pick up the bigger value of friction. So your friction should be at least, friction coefficient should be at least 0.2 in this case.